Thank you very much, Sebastian. Welcome, everybody. I'm going to present today the example of nanoplasmas, a case where an idea from research has reached the market as a product. So we are a spin-off company from Demokritos, which is the largest interdisciplinary research center in Greece. The company has 15 years of research experience. The founders in total have more than 150 publication papers, and we have reached a number of 6 patents. Also, as a spin-off company, we have acquired 2 rounds of venture capital funding. And because we're a company that brings products to the markets, we have also acquired ISO certificates, the 9001 and the ISO 13485. This is the team of nanoplasmas. On the top, you will see the 4 starting founders. They are all researchers and academics, and they are experts in the fields of microfluidics, and nanotechnology, the technology based on which our products are made. Also here you see some more of our advisors and former colleagues that have supported the company in its growth. And in the bottom, it's my colleague from the Research and Development Department and myself. I am in the business development of nanoplasmas. I joined the team quite recently in May 2024. And myself, I have a background in biochemistry and biotechnology. I also have a research master in the field. But then I decided to move on the business side of science. I gained experience in business roles and also an MBA. And this is where I am now, in a biotech company, working on its business side. So the vision of nanoplasmas is to disrupt the diagnostics market with ultra-fast and ultra-precise detection kits. I'm going to say a few words now in the science behind our vision, which is plasma nanotechnology. Our technology is based on the use of a plasma reactor to process polymeric surfaces, plastic. In our cases, the PMMA plastic, commonly known as plexiglass. And we use plasma nanotechnology to modify the surface morphology of the plexiglass and give it a structure shown in the image at the upper right side. And this process is called etching. Now, I will try to explain this as best as possible, but I'm not a nanotechnologist myself, so I will do my best. So inside the reactor, a vacuum area is created, and the inner walls of the reactor are metallic. In our case, they're aluminum walls. In the reactor, we introduce gases, either individually or in combinations, depending on what we want to achieve. In our case, we introduce oxygen gas. So plasma is generated by applying a voltage difference, which provides the gas with the necessary energy to form a mixture consisting of ions, free radicals, and electrons, the plasma, which move in high speeds in there. This is oxygen plasma, and it performs 2 key actions in our setup. First, it heats the reactor walls and extracts aluminum and aluminum oxide ions. Second, the oxygen plasma interacts with our polymeric surface, which is in the base reactor, and etches it. The etching can be controlled depending on the conditions we choose. The polymeric surface at various points, acting as inhibitors.
Sorry,
yes.
There was an interruption, a hiccup with your network, it seems. Would you repeat the part from the oxygen plasma interacting with the surface, please?
Yes. So I will say a few words before that. So we introduce oxygen plasma, which performs two key actions in our setup. First, it hits the reactor walls and extracts aluminum and aluminum oxide ions. Second, the oxygen plasma interacts with our polymeric surface, which we have placed it at the base of the reactor, and etches it, we choose. So simultaneously, the metallic ions deposit onto the polymeric surface at various points, acting as inhibitors to the etching process and protecting it at those spots. I think now we didn't miss anything, right? So
jumping in between still, but I think it's something we can with both takes get together in the cutting. So no worries. I think for the audience was clear enough. If not, please protest from
It
from the
was
lecture
okay.
hall.
It was okay.
it
A little bit
cool?
cut it. It was breaking up the connection, but no worries. You can keep going.
So,
Perfect.
okay, if you want, I can switch networks because I also lost a bit Sebastian.
Maybe that's going to be better, yeah, if you have the chance.
Okay, let's.
Well, yeah, no, it's okay. Yeah, okay, go ahead.
I switched networks. I will go ahead and I can always send you in text describing the process if you have missed it somewhere. So if it's useful.
Thanks.
Okay, so I will move on now. As we said, we have ions that have been created inside the reactor, and they are bombing the polymeric surface. And through this bombing, where oxygen plasma etches the polymeric surface while the metallic ions protect it, the surface acquires an intense three-dimensional morphology, as you see at the top right image here. And in this way, the total surface of the area has been increased. Additionally, the oxygen plasma makes the surface hydrophilic, which is advantageous when we want to have biomolecules or even entire cells adhere on the surface. Also, the slide shows two examples on how this technology can be applied. On the right bottom, these are microarrays where plasma-treated surfaces are used for the immobilization of biomolecules. And on the left bottom, it's an example of microfluidics, where plasma-treated surfaces are used for immobilizing cells. Now, this slide shows the result of plasma nanotechnology I was describing on a polymeric surface in a close-up before and after the treatment. You can see very well now this spongy morphology that the surface gets, which increases its total surface. As I said, our company has 6 patents acquired on this technology, and now I'm going to say what products has Nanoplasmas created using these nanomodified polymeric surfaces, which are the diagnostic chips, also known as laboratory-on-a-chip devices, like the one on the image on the right side, which feature these small channels. Using the etching process I described earlier, the surface is etched and becomes hydrophilic, enabling the immobilization of biomolecules in high concentrations within these channels, and in our case, we use antibodies. The two main advantages offered by our diagnostic chips are that, one, due to the increased concentration of antibodies on the chips, our diagnostic method is highly sensitive and provides very accurate results. And number two, there is no need for additional liquid chemistry protocols, allowing chemical analysis to be performed all directly onto the chip. While normally in a conventional laboratory, one would require multiple stages and machines and significantly more time to run the same analysis. So on our lab-on-chip technology, the chip is microfluidics based, and the analysis is done on a handheld, easy to use chip. And our detection method is a molecular method. So an inside-specific antibody, as I said, as well as a DNA amplification method is used in combination with a chromogenic detection approach that I will show you in the coming slides. As a result, in a very short time, the presence of the pathogen can be detected and quantified with high sensitivity and accuracy. And this is due to the double specificity that comes from the antibody in combination with the nucleic acid amplification test, which is similar to the PCR method, but it needs just one temperature in order to have the whole amplification done. So this is our product. It's a Legionella detection kit. Legionella is a pathogen. It's a bacteria that can grow in the water. The conditions for it to grow are stagnant water in temperatures between 25 to 60 degrees. This situation is not very weird, this kind of condition. It's actually easy to happen within water pipes, in buildings and pools and water tanks. And also it just takes about 8 to 10 days to grow. So facility managers and anyone basically in the market who has water pipes and water tanks and also air conditioning systems, they are obliged by law to test their facilities. Normally, how the test is done nowadays is that a water sample is taken and it's being sent to a laboratory, and there the whole analysis for the quantification of the Legionella growth of the Legionella bacteria takes about 10 days. However, this is a very sensitive period time-wise if there is already a problem of Legionella, for example, within a hotel, because in the same time the bacteria grows in the facilities, and the way it's being transmitted is through droplets, and then people may inhale it, and when they inhale it, they get a very serious pneumonia with a 10% death rate. So with our solution, the user gets ultra fast and very reliable Legionella screening and also quantification just within 3 hours. So this is one of our competitive advantages, the time reduction. You can get water or swab environmental samples with our kit, and we have the kit available in 2 options depending the needs of the customer, with just 1 sample per chip to run at the same time, or 5 samples per chip to run at the same time. So a small hotel, for example, they may need just 1 analysis to be done at the same time, at one time, or a big hotel with more spots to analyze. They may opt for the 5 analyses at the same time. And also we have created a reader for our chips for the reading of the results based on a colorimetric approach. So you see here on the left side of the screen the reader. It has slots for 2 chips at the same time. So the user can put the chip inside, and then the reaction starts, the amplification of the DNA of the Legionella in the case of the Legionella detection and quantification chip. And then there is a camera inside that detects a change in the color that happens when the reaction develops. And in this way, the quantification happens, and the analyzer shows the quantification result on the screen. this analyzer is very portable. It's less than 1 kilo. And that's also another competitive advantage of ours, because not just a laboratory not only laboratories can be our clients, but actually the hotels themselves or boats that are in remote areas in the sea and they want to test their water tanks for Legionella. With our solution, they can get our portable analyzer on board in the case of a ship or on the site where the need is in general. And the users themselves, they can just analyze their water anytime and they don't have to send samples to a laboratory and wait. So here are some of our selected partners and customers. We have been collaborating with institutes and other spin-off companies from the Democritos Center itself. Like nanometrices and theta matrices, which is here on the screen. We have been collaborating with laboratories in Greece to develop our method, and also they have been our clients. In the past, we also had a project with Highway, and at the bottom middle, you see Medicon. This is a company in Greece, which is they are our subcontractor for the production of our chips. Now I'm going to show you a bit of our business traction. The company was launched in 2016. In 2017, we had the Horizon 2020 project acquired in the field of food. As I said, we have a fund, a venture capital fund also supporting us. So we received 2 rounds of funding from them, one in 2019 and one in 2021. In 2020, we acquired private and Greek research projects. In 2022, the company acquired certifications, the ISOs that I mentioned earlier, and also CE and IVD certificates for the COVID kit that we had at the market at that time due to the needs globally on COVID tests. In 2022, we developed the software for the analysis of the chips that now is incorporated in the device I showed you. In 2022, also big Greek hospitals evaluated our COVID kit. An example of our revenues in 2023 was 122K. Lately we are focusing on sales and business development, and we are focusing on agreements with private companies for the Legionella kit. Overall, the nanoplasma plasma treatment nanotechnology can act as a broad platform able to disrupt an enormous number of markets, not only because, for example, for the Legionella pathogen, you get companies and institutions from different fields interested to test their water, but also because we are able to change a bit our product. For example, as you saw, we have for Legionella and we also had for COVID, and we can change it also to detect other pathogens. And I will show you an example of our pipeline down the line of this presentation. This is a product we had for COVID. Again, it is a microfluidic based kit. We were able to have it for 1 or up to 4 sample to have it. The user was able to run up to 4 samples per chip. And again, it's based on a nucleic acid amplification test. And this is the product for which we had to acquire the CE and the IVD certificate in order to be able to bring it to the market. Now, the size of the markets that we have been looking at was the in vitro diagnostics market, which is a $110 billion market, and it's expected to hit the $130 billion point by 2030. This food safety market is expected to reach the $35.6 billion point at 2030, and the water analysis market is expected to hit the $6 billion point at 2030. These are very big markets, and there is space for us to get a share from there, and that's why it's very interesting for us company-wise. This is an example of our customer pipeline. Different customers different customer segments are interested more in different products. So, for example, cruise ships, ship owners, food and water diagnostic providers were interested and are interested for the Legionella detection kit. We are in contact with ship owners and companies that provide analysis for boats for our product for the detection of Legionella. And for example, hospitals were more interested, of course, on the product for the detection of COVID. And our products pipeline, we are interested to develop, as I said, our kit, our product for more pathogens. And in the food and the environmental analysis market, we're also interested to develop it for Listeria and Salmonella and so on. That was it from me. You can always reach to us also from our website, which is here. And thank you very much for your attention, and I'm here for questions.
Thank you very much for the interesting presentation. Very important and interesting technology indeed. So maybe first of all, are there any questions from the lecture hall?
Yeah, I have a question. Because maybe thank you very much for the presentation, Alexandra. I have a question because we are working in a project with Legionella and fast detection, and we are and especially on wastewater treatment and wastewater and industrial water, and most of our problems are related to the complex matrix of the samples. In your case, which is the because I could not listen all, but in your case, in which specific applications are you really more focused, like in clean water effluents or really dirty water effluents, like wastewater effluents?
So I know from our R&D team that usually addresses these questions that we are able, we can detect Legionella not just in pure clean water, but also it can be a bit dirty. But because the chamber, it's a small chamber, they have seen problems with very, very dirty water. For example, water coming from zoo, from zoo, which is very dense. There we have a problem, but it doesn't have to be totally clear water.
Yeah. Okay.
If you're interested in the specifics, I can consult. We can have a follow-up if this is important for you. So what kind of wastewater analysis are you interested in?
No, what we are comparing, we have a project now that we are comparing 4 different methods from different industrial technology providers, and we are still struggling with the complex matrix. So when we have a water with low transmission or a little bit of solid particles there, then those tests are struggling because still they need to be optimized for the application. Normally they come from clean waters, let's call it cooling tower effluents, that is pretty clean with some chemicals. But at the moment that you start putting nutrients and you put where you have nutrients or you have other substances in the water, then the Legionella, Legionella is still there, but the efficiency to measure it goes down due to the difficulties of the water. And this is still on research. I was just asking if you really make a stress test of your test to see how difficult it could be and how reliable it keeps. how difficult it could be the water and how reliable it gives the test. But I think that this is an interesting question for me, but maybe you don't have the answer. Happy to continue via email and
Yes.
to see what you do, because I think it's maybe you don't have all the answers.
Great. So I think Sebastian can send my email with you.
Yeah, I already have it. Don't worry.
And
Yeah.
please send me your question, and I'm going to bring on board our team.
Okay.
One correction. It's not because of the microfluidic chamber. Of course, we have a filtration step before that.
Okay.
So it's the filtration step that at the point of time, I understand there is the limitation.
Yeah. Okay.
But let's
makes
bring
sense,
on board
yeah.
my science team.
Perfect.
And
Yeah. Perfect.
Thank you for your question.
That's it, Sebastian.
I also have some questions, to be honest.
Yes.
So as far as I understand, so far you are focusing on Legionella, right? Are there also other bacteria that you have tried or that you're intending to try and detect with this method?
Well, I know that the team has been looking also at Salmonella, and I think also on an R&D basis. And in some conversations that we are having in the market, when we are mentioning that our solution, the consumables, the chips, and an analyzer are ready to also be switched, also they can be adapted also to support analysis for Salmonella, the industry is very interested. But my focus is sales and business. So from my perspective, at the moment, we are focused on Legionella.
I understand that. Yeah, maybe just to conclude that line of thought, and then some other questions as well. But my question came from the direction that I'm collaborating with colleagues at our health science faculty, where we're using atmospheric plasmas to disinfect surfaces and to get rid of biofilms. So these are mostly connected to other bacteria, let's say multi-resistant bacteria that you find in hospitals, for example. And those groups in the health science faculty they're also very much collaborating, for example, with dentists, where, of course, very high water standards are needed for all the flushing and for all their procedures. So testing those waters, cleaning the waters and testing them properly for all sorts of different bacteria is, of course, a huge topic for them. So that's why I'm asking, because definitely that's going to be of interest for them. Maybe also a good opportunity, or maybe some opportunity, probably more for your science team, development team, to connect with them and maybe see if there are some opportunities.
Sure, please please go ahead and send me an email on that. And I can add, I can add that we are a spin-off of the nanotechnology group, and there's also another company that's a spin-off from the same group that they're also working with modified surfaces with plasma treatment. So maybe your question will be applicable to them. I don't know. But send it to us, and because we have a team of nanotechnologists around us working on surfaces, and I have read about the approach you mentioned on in surfaces. Yeah, please send me your
Yes, I think we have other questions, do we? Yes, please go ahead.
Yeah, I have a question. It's great to see how you, with your company, bridge the gap between just raw knowledge and how you can use it in real life scenarios. But what I wonder is, in the process of bridging that gap, did you also incorporate or embed in that process some type of user involvement that you already knew who would be able to use it, and then together with them create the product?
This is a great question. I wasn't part of the team when the product was being developed, because I just joined the team in 2016. In 2024. The company is established since 2016. So when I joined the team, the product was already there. for the detection of the Legionella, and also the analyzer was just almost ready. So I know that the reason the company chose to develop a chip for detecting Legionella was also because they knew that there was a legislation coming up from a European level that was about to enforce how many times companies would have by law to test their waters for Legionella. They were hoping for more tests. Now they're as the year passed and the law came in action, it's only 2 times a year. So it wasn't a user that they had data from, but it was from a legislation side that they had some indication why this bacteria is an interesting business-wise to focus on. Your question is great because when you are growing a startup, you have this phase where you have a lot of ideas and you don't know which one to choose. So at that point, what you need to do is you need to get your hypothesis. You need to work with a business model canvas. I don't know, maybe you know this approach. And then you have your hypothesis and you do need to speak with the market. And you do need to go out and find, for example, in our case, hotels and SIPs and whoever else you think would be interested in your product. And you need to ask them, hey, do you have this problem? And would you be interested in a solution like the one we have? Because if you're very deep into developing your product, and a product like ours, which is deep tech, and you need a lot of funding and a lot of hours in the lab to develop it, and then you go in the market and the market doesn't really need it, then you have a problem. So it's a bit of a problem like the chicken and the egg, what you do first. I hope I answered your question somehow.
Yeah. And on that, some maybe a follow-up, what is easier for you to answer because you're in it now. And I wonder, you talked about in a slide, I think, about what other types of products you could do with the same principle. Do you do that based on insights from the market, from users you get with whom you have relations?
Well, now, because we are speaking with the market for the Legionella, and we are also telling them, we're interested to develop it also from for other pathogens. When we are speaking about Salmonella, we see a lot of interest. So now that we have access to potential customers and we are dropping our idea, we have these discussions and we see, we get the vibe back from them.
All right, thank you. That's clear.
Thank you very much as well for your question. It's a very good question.
So understood you joined the team after they already got the initial seed funding. Did I get that point right?
Mm-hmm.
Since we had in the last lecture earlier this week, a company that's exactly this step ahead, and now with the first kind of seed funding right out of the lab, and potentially also a couple of the other students and PhDs that were listening in who are also thinking of going into this kind of a path. Any big tips for how to best handle this? Because I mean, a lot of us are from the fields, are not so much in the startup world, maybe have not so much of the entrepreneurial experience. You saw that mentioning the business model canvas, at least some nodding was in the audience, so at least some have heard these things, but it's not our core field, right? So long story to introduce, but maybe do you have some good suggestions where to look and how to prepare for this kind of path? I mean, it's obvious to get a professional on board like yourself at that point. But yeah, any good advice there or any lessons learned from this project?
So if I understand correctly, you mean how to start at the point where you have no funding yet. You are only
or the first
team of
very first
researchers.
seed funding. Either no funding yet, or the very
You don't
first like proof of concept or seed kind of pre-seed kind of funding. So if you're at that point, how to continue there, and what to regard, take care of, what things maybe we as the researchers, engineers, inventors may not have on our radar. You mentioned, of course, looking into the market and getting there, but may any good
so how
advice
to move
there?
on in this in respect to so in respect to gaining more funding and also getting more traction towards the market, right?
I guess.
I think your question is both wise.
Yes. So it seems we're losing you again. Seems you're breaking up again.
Such a difficult question, Sebastian. No, I'm not joking. I'm joking.
I lost you a bit.
Wait. Yeah, you are back, Alexandra. Now, maybe shall we repeat the question?
Hi.
Maybe.
I think I heard the question,
Perfect.
and that it was for. So I was wondering if you just mean only for funding wise, or also how to get into the market, or is it both?
What aspects do you see most important, considering that we have an audience that's more on the like tech inventor side and less on the business startup side, right? So what's your most important advice to us? That's the question. Your most important, valuable insight.
Great. Okay. So this is an excellent question, because I have been myself a researcher, a scientist. So I have had the brain of a scientist, and then I chose to get the brain of a business person. So a very big difference is that when you are in a research environment, it's all about innovation and how to get the most new idea, most exciting, and be very accurate. And how can I say it? You maybe get scientists are working in an amazing world with new ideas, but sometimes this world is far from the market. And the difficult thing to do is to switch the way you think and think like an average person in the market your product is going to be addressed. So you really need to start thinking on needs based, like, okay, what does the customer really need? I may have an amazing idea with this pen that can also be fluorescent in the dark, for example. Amazing, but does somebody really need the pen to be fluorescent in the dark? Is this a real need? And at that point, it doesn't really matter as a researcher. Maybe you are top of your field. Maybe you're really an excellent person in your field. But you need to leave this aside and look at the market. So when you really understand what the market needs, and then you can start talking numbers, and you can say, okay, the market is 110 billion, for example, the market. How much can I gain from that? And when you start having numbers, then you can go to the funding, to the VC, the venture capital funds, and present your idea, not only on the technical side, but also on the business side, and say, look, I think that I can claim this size of the market, and put numbers, put some estimation. Don't be afraid to estimate money and show it to them. And you have to also be prepared that when you're talking with VC funds, they are going to become your business partners. They will invest and take part of the business, and then they will have an opinion, and you need to also have open ears, because these are people from a different type of field, with a different type of view on how to proceed in projects than we have when we're in a lab. These are some few tips. But number one, start thinking from the needs of an average person outside of a lab that may be using your technology.
Great. Thanks for the good insights and the good advice. Are there any other questions from the audience? Everything clear, it seems? Perfect. Then thank you very much for the interesting lecture again. I think definitely a few of us will be back in, a couple of us will be back in touch with you and the colleagues to see for also possible future steps together, maybe to look into one or the other thing that was mentioned. So yeah, thanks a lot. Was very nice, was very interesting. And then yeah, you all have a nice weekend and see you soon.
Great. Thank you too. Have a nice weekend, everybody, and great discussions. Thank you.
Yeah, thank you very
Looking
much for
forward to
your
your
time.
emails.
See you.
Thank you very much.
Bye bye.